This is section 8.3. We're going to be talking about compound interest. Compound interest is interest computed on the original principal as well as on any accumulated interest. So basically what you're doing is you're getting interest on interest that you've already earned. The formula, if we have compound interest, A is equal to P times 1 plus r over n raised to the nt. A is called the account's future value. That's what we're going to have in the future. P is the principal. That's also called the present value. R is the interest rate. N is the number of times the interest is compounded per year, and T is the number of years. So a couple things to be aware of. N is the number of compoundings per year, and T has to be in years. So let's suppose I tell you that I'm compounding monthly. If I'm compounding monthly, then N is equal to 12 because there's 12 months in a year. If I tell you it's compounded annually, annually means once per year, which tells you that N is equal to 1. So let's suppose I tell you that it's compounded daily. Well, how many days are there in a year? There are 365, although most of the time your homework will tell you to use 360. Just watch out for the directions. What else do you see? Compounded quarterly. Well, you can remember quarterly because how many quarters are there in a dollar? Well, there are 4 quarters in a dollar. There are 4 quarters in a year, so quarterly, N is equal to 4. All right, and I think, oh, semi-annual, that's the one I missed. Semi-annually, that means twice per year, so N is equal to 2. So let's do an example. You deposit $2,000 in a savings account, which has an interest rate of 6%. Find the amount, A, of money in the account after 3 years, subject to compounded interest, and find the interest itself. So A will tell you the amount of money in the bank, and what we're looking for is, we're also looking for just the interest itself. So we are going to be compounding annually. It doesn't say, so we're going to assume that it's compounded annually. In your homework it should say. So A is equal to the principal, which is 2,000, times 1 plus the interest rate. Remember, it has to go in as a decimal, divided by N. N is the number of times it's compounded per year. It's compounded annually, so N is equal to 1. Raised to the N times T. We already decided that N was equal to 1, and it's for 3 years. So here's how you do this problem. You need to start with the exponent. So 1 plus, by the way, 0.06 divided by 1 is 0.06, and 1 times 3 is 3. All right. So when you're doing this on your calculator, this is decimal, you're going to first divide the interest rate by N, keep that number in your calculator, then you're going to add 1, keep that number in your calculator, then you are going to raise it to the 3rd power, keep that number in your calculator, and multiply finally by 2,000. When you do that, you should get amount is equal to $2,382.03. Now, this is how much is in your bank account. Part B says how much is the interest. What is just the interest itself? Well, if I have $2,382.03 in the bank, and I deposited $2,000, to figure out just the interest itself, what the bank actually gave me, I'm going to subtract those two numbers, and the amount of interest that the bank gave me is $382.03. All right, you deposit $7,500 in a savings account that has an interest rate of 6%. Interest is compounded monthly. All right, so A is equal to the principal, $7,500, 1 plus the interest rate of 6%, compounded monthly. Well, how many months are there in a year? That means N is equal to 12. N is equal to 12 again, and we are keeping it in there for 5 years. So, first thing you're going to do is multiply the 12 times 5. And get 60. Next thing you're going to do is take 0.06 and divide it by 12. Keep that number in your calculator. Add 1. Still keep the number in your calculator. Raise that number that you have in your calculator to the 60 power. And finally, multiply by 7,500. And you should have approximately $10,000 in the bank. And part B says, how much of that is interest? Well, we have $10,000, but we started with $7,500. So to figure out how much the bank gave us in interest, we subtract the two, and the bank gave us $2,616 $2,616.38 to be precise. All right, there's another thing called continuous compounding. Compounding periods increase indefinitely. All right, so if it's a specific number of compoundings per year, you use the formula we were just doing. For continuous compounding, we use a different formula. This is E, that's an irrational number. It will be on your calculator. It's the small e, usually e to the x is how it's written. It is not the capital E. Do not use capital E, that won't work. So on your calculator you need the small e, not the capital E. You decide to invest $8,000 for 6 years, and you have a choice between two accounts. The first pays 7% per year, compounded monthly. Second pays 6.85%, which sounds worse, compounded continuously. Which is the better investment? Guys, when I'm looking for the better investment, I want more money. I want more, I want more. Remember that commercial? I want more. More is better. So I look at the amount at the end and figure out which one gives me more. And that's going to be the better investment. So I'm compounding monthly, so I have $8,000 at 7% compounded monthly for 6 years. Plug that into your calculator, see what you get. The other one, the other account, I still have my $8,000 that I'm depositing. I'm going to use E, that's an irrational number, kind of like pi, but it's, different number obviously. Raised to the interest rate, 0.0685 times the number of years, which is 6. And figure out which one gives me more money. Whichever one gives me more money, that's the one I want. And I think I put that interest down wrong. 0.0685, I believe, times my 6 years. All right. So, at the 7%, I end up with approximately $12,000. If I have continuous compounding, I again end up with $12,000, but not quite as much as the 12,160. I only got 12,066. So the first one at 7% was a better deal. So better investment, more money. All right, if we take that formula, A is equal to P1 plus R over N raised to the NT, and solve for P, to get P by itself, then, so I would divide both sides by 1 plus R over N to the NT, cancel, cancel, 1 plus R over N to the NT, and ta-da! Here's the present value formula, which really is not a different formula, it's just solving for a different variable. So what we're looking for is the present value or the principal. Okay, I know the amount. I'm trying to decide or find the present value or the principal. How much money should be deposited? If you earn 8% compounded monthly, so that the amount that I have in 5 years is $20,000. So I want the amount that I have in 5 years to be $20,000. I still have 1 over my interest rate over N. It's compounded monthly, so my N is 12. Raised to the 12 times, how many years? 5 years. All right, this one is a little bit trickier to plug into your calculator, but you're still going to multiply those first, then you're going to divide, then you're going to add 1. The difference being you can't keep the whole thing in your calculator. Once you get the bottom done, you have to actually clear that out, take 20,000 divided by the denominator. All right, so you would multiply the 12 times the 5, you would divide, you would add the 1, you would raise to the power, and write that number down. As many decimals as you can possibly write down. Then you take 20,000 divided by the number you just wrote down, and this is how much you have to deposit today in order to have $20,000 in 5 years. Effective annual yield, or the effective rate, is the simple interest rate that produces simple interest, no compounding, that produces the same amount of money at the end of 1 year as when the account is subjected to compound interest. Okay, so this is the effective annual yield is a way of comparing apples to apples. If you're comparing simple interest versus compounded interest versus compounded monthly versus compounded daily versus compounded continuously, it gets too confusing. There's no way to, those are apples and oranges, no way to compare. So effective annual rate kind of gets rid of all that compounding stuff so that we're comparing the same thing. All right, you deposit $4,000 in an account that pays 8% compounded monthly. First thing we're going to do is find the future value after 1 year. Remember, this is only for 1 year. Okay, so A, that's our future value, the amount we have in our bank. Principal, 1 plus my interest rate, compounded monthly, N is equal to 12, and it's in for 1 year. Okay, so plug that in. That's the amount that is in the bank. Okay, so I have $4,332 in the bank at this time after 1 year. Okay, so how much of that was interest? Well, I deposited $4,000, but I have $4,300 in the bank. So how much of that is interest? Well, I've got $332 just in interest. Okay, so the question is, how could I get $332 of interest if all I were getting were simple interest? So remember simple interest, PRT, interest, principal, rate, time. So I know what the interest is, right? It's $332. Principal, I deposited $4,000. I'm trying to figure out what the interest rate is, and I put it in for 1 year. Okay, so you'd solve for R, and you get an interest rate of 8.3%. So by doing this to multiple accounts, you would be able to compare the effective annual yield and see which gives you basically the better deal. I want you to do 2 through 28 even. I also want you to do 40 and 42.